A teaspoon of matter weighs billions of tons. An object no larger than a city, yet carrying the mass of an entire sun. That is a neutron star. It spins at more than 700 rotations per second, generating immense forces powerful enough to bend light and slow time. If you set foot on its surface, you would be crushed into a layer of matter thinner than a strand of hair in an instant. Beneath a crust harder than steel by billions of times lies a bizarre world of matter that science still does not fully understand. A neutron star exists right at the final boundary before an object collapses into a black hole. And perhaps it is one of the most terrifying entities the universe has ever created. To understand how a neutron star is born, we have to begin with giant stars, about 10 to 20 times the mass of the Sun. These stars burn brilliantly for millions of years, powerful like enormous cosmic flames. Their light is bright enough to illuminate vast regions of a galaxy. But then, everything begins to change. When the nuclear fuel in the core is completely exhausted, the star loses the only source of power holding gravity back. The outward pressure weakens, then disappears entirely. At that moment, gravity, that invisible but utterly ruthless force, immediately takes over. In just a few brief seconds, the star's enormous mass collapses inward at terrifying speed, reaching up to 1/4 the speed of light. An immense sphere of fire is crushed down, shrinking until it is reduced to an incredibly tiny point. And at that moment, the star makes one final act of resistance with a cataclysmic explosion, a supernova. This explosion shines brighter than billions of suns and is powerful enough to be seen from tens of millions of light years away. The star's outer layers are torn apart and blasted into space at incredible speed, carrying gold, uranium, and many other heavy elements with them. But not everything is destroyed. At the center of the explosion, the remaining core does not fly outward. Instead, it is crushed by gravity with unimaginable force. The enormous mass of the giant star is packed into a space only about 20 kilometers wide, smaller than many major cities on Earth. From those ashes and that cataclysmic explosion, a new object is born. That is a neutron star. But do not let its size fool you. Its mass is enormous, about 1.4 to 2 times the mass of the Sun. The giant star's immense mass is compressed into that tiny space. And this is where things become truly insane. Imagine just a single teaspoon of neutron star matter. It would weigh about 6 billion tons, comparable to the mass of Mount Everest. Matter here is so dense that there is almost no empty space left. Electrons and protons are crushed together, merging into a mass of pure neutrons, an ultra-dense nuclear ocean. The gravity on a neutron star's surface is even more horrifying, billions of times stronger than Earth's. If a person set foot there, their body would be crushed instantly into a layer thinner than a sheet of paper. Gravity even bends space-time itself. Time on a neutron star passes about 30% slower than on Earth. That means 1 hour there would equal only about 40 minutes on Earth. From the outside, a neutron star looks like a small dark sphere, nearly motionless in space. But inside is a completely different world, where matter is pushed to extreme limits. Just beneath the ultra-hard crust lies the region known as nuclear pasta. Here, immense pressure deforms atomic nuclei. They stretch, bend, and stack into bizarre shapes like spaghetti or lasagna. This may be the hardest form of matter in the universe. Deeper down, the boundary between solid and liquid disappears. A region of superfluid neutrons emerges. This matter has almost no friction, causing a phenomenon called a glitch, when a neutron star suddenly spins faster for an instant. At the center lies the greatest mystery of all. The pressure there is so immense it cannot be recreated on Earth. One hypothesis suggests neutrons break apart into quarks, creating quark soup, the kind of matter thought to have existed after the Big Bang. Another, even more frightening hypothesis is strange matter. If it exists, it could convert ordinary matter into itself, spreading like a chain reaction. It is no accident that the internal structure of a neutron star has been called the Devil's Kitchen. From the ultra-hard crust to deformed nuclear structures to the superfluid region and the mysterious central core, each layer pushes matter to limits the human mind can barely comprehend. Not all neutron stars are the same. Some are nearly silent, drifting through darkness and extremely difficult to detect. But others become some of the most extreme machines nature has ever created. Among them, two stand out the most: pulsars and magnetars. Pulsars are neutron stars spinning at astonishing speeds. Some rotate more than 700 times per second. At those speeds, they emit powerful beams of radiation from their two poles. These beams sweep through space like the light of a lighthouse. Each time one of those beams points toward Earth, we receive a highly regular pulse. That is why they are called pulsars. When the first pulsar was discovered in 1967, its signal was so perfectly regular that scientists briefly suspected it might be a signal from extraterrestrial intelligence. But pulsars are more than strange phenomena. They have been used as cosmic landmarks. On the golden records aboard Voyager 1 and Voyager 2, NASA engraved a map showing Earth's location based on 14 pulsars. Because their pulses are extraordinarily stable, they function like cosmic lighthouses for navigation across the galaxy. In a sense, humanity used the remnants of dead stars themselves to send its coordinates into the universe. Yet pulsars are anything but gentle. They are powerful radiation sources spinning endlessly in the dark. And if pulsars are terrifying because of speed and radiation, magnetars are even more extreme. Magnetars are neutron stars with the strongest magnetic fields ever known. Their magnetic fields are trillions of times stronger than Earth's. If a magnetar appeared as close as the distance between Earth and the Moon, it could disable every electronic device on the planet. If it came even closer, that magnetic field could disrupt atomic structure itself, disturbing the bonds inside living matter. Everything could be warped at the most fundamental level. Sometimes a magnetar's crust can no longer withstand the pressure inside and cracks open. When that happens, a starquake erupts, releasing colossal energy in an instant, more than the sun emits in hundreds of thousands of years.